Here I am with our production test bench again. We have production unit number 2, I guess. A gentleman named Chad Fellick with Solar Home in Auburn, California. Was quite insistent that he receive a unit, even though we do not have our queef in yet. He wanted to do measurements and begin installation on his work on a show car they're building for their solar business. It's going to be a 1934 Ford Roadster from Factory 5, who does a very deluxe kit car and a very pretty 34 Roadster. Chad is going to build that up with a Tesla Model S rear drivetrain. Not that he needs it for racing or anything, but this is intended to be a very sort of top of the mark electric car conversion to show off at car shows and so forth with literature for their solar panel system. And they have a very good one out there. If you recall, we sell some solar panels with cells made from a company here in the United States, U.S. Solar, I think. They have achieved 21 or 22% efficiency on their cells. We were getting panels made from those cells from China because they get them made from there. This is very hilarious, except sick. They filed a complaint with the U.S. Department of Commerce, and the outshoot of that is a 250% tariff on the solar panels we were getting, little flexible ones that have nothing to do with what these guys were selling or with homes or anything else. But in any event, it's a 250% tariff. China doesn't pay the tariff, by the way. All that happens is U.S. companies that are importing it pay the tariff, and often in arrears and without knowing about it. I was fortunate to find out about it before reordering, and so we're out of 180-watt solar panels. But one of the ways this company maintains kind of a strict control of its pricing and branding and so forth is they will not sell those panels to you or I. They only sell it to a licensed installer. And what this does is let them cozy up with the installers so that, for example, if a solar installer comes in and gives you a bid for a solar system on your house, or as we had done here on the shop, we got a bid for $110,000. And a list of the materials they would use. Well, I could immediately get on eBay and tell the guy, well, this is $36,000 worth of stuff. Where does the rest of the $110,000 come in? And he just kind of turned red in the face. Well, if you don't want to, pay for quality, you can get cheap stuff. It's just the same stuff. And so there's kind of a bottom feeder mentality at work to beat these guys out of their profit on doing an installation. U.S. Solar has fixed that by they don't have pricing and you can't buy them. You can only buy them through the licensed installers, and only they know what their costs are, and I don't think they'd be telling you. Anyway, they've got a very nice company out there installing solar and want to build a very nice electric car doing that. So he wants the system right now, and I'll mail him the queef later. And so here we've got our production bench, and I've got an EVIC and a JevQ, our PKP 200, a fuse box, our throttle, a wiring harness, and down here is a little ISA scale current sensor that I've been doing quite a bit of work this week, kind of redoing the way it operates, and I don't think I've really got it doing what I want yet. But it's doing something. So let's fire it up, and I'll show you this running. Not that you haven't seen it before. There we get this. I get a brake. Here's my EVTV panels come up. My PKP. I'm going to press the brake right way over and hit drive. And here we go. Our wheels take off. I have removed this full subclip from our sport bench, or our test roll around, and it's now on a pallet, 48 by 96, ready for shipment. We will add a box with these piece parts to control it to the box. It's very nice and smooth. If you recall, we had this on the roll-around jig and with tires on it. We're not going to ship any with tires. You can get tires anywhere. But that sort of thing, I can turn creep down with my canned switch pad and then put it back up with this. I can show RPM. Pretty easily. I guess I've got to lean across this in order to do anything with it, so that's kind of a problem, but we can adjust our regenerative braking either from the switch or from our panel here, and reset our odometer, our trip meter, our capacity. We can set up in here. I'm at 101 amp hours. I can drop that down here. Let's say I have a 93 amp hour battery. I do have some batteries on the way from Shenzhen, China. These are nickel cobalt manganese oxide cells as Tesla originally used, but I've had them kind of specially formulated for power to put out 10C continuous and 20C in a 100 amp hour form factor, and that's going to be our NCM cell. The next thing, Calb never really came out with one, so I found another company, and I've been working with them. We'll see what we get. Ordering from China is always an adventure, but I'm hopeful that this will be kind of a next generation cell, a little higher energy density, but I've had these kind of biased toward power density, and the reason is we don't really want to have a 100 kilowatt battery pack of 1,250 pounds. That's just not feasible in most of our builds. However, we do want a good amount of power out, and the nickel cobalt manganese oxide cells typically have a fairly low power output and a high energy density. Of course, you can kind of bias that by the thickness and the granularity of the cathode material. Today, Tesla is going to 90 and 100 kilowatt hours in their cars. Still 1,100 pounds, but they are using the next kind of version, an NCA battery, a nickel cobalt aluminum oxide with quite a bit of silicon in the anode, kind of a silicon graphite mixture. Silicon breaks down, and so the life of these cells is not very good, but the energy density is a freight. So that's kind of where the real battery progress is going. People announce all kinds of absolutely stunning breakthroughs that are never going to be a product. But in the real product, it kind of goes from to the NCM nickel cobalt manganese cells to the next one after that is nickel cobalt aluminum oxide, and so we're working on that. Tesla has done fantastic since last we spoke. They're now up to about just under 400,000 orders of the Tesla Model 3. But more importantly, on SpaceX, Elon just hit it out of the park. Have you seen the landing of this last launch, a International Space Station Dragon replenishment launch? He stuck the first stage. He parked it right on a kind of a pitching, sloping deck out in the middle of the Atlantic in a stunning recovery. Let's take a look. Chingawa stuck it like a lawn chart. Now, they had done this ashore, but they had had a couple of bad failures at sea trying to land it on a drone ship. And in this case, he stuck it. The import of this is beyond what has been picked up in the media. Our entire society is kind of oblivious to it, but this is a one of those two order of magnitude leaps that changes everything with regards to getting into space. That rocket is $60 million. Normally you launch something, it's another $60 million. By having the ability to recover that first stage, to refuel that is a couple of $100,000. And to give it a quick detail and put it back on the pad might be another $100,000 or so. And so for less than $500,000, you can launch it again. And that changes the entire economics. If we go from 500,000 to 5 million to 50 million, that's two orders of magnitude. They also successfully birthed, not docked, but birthed the Dragon capsule with the International Space Station. Let's take a look.
Dragon now just 85 meters away from the International Space Station, flying over the South Atlantic. Its approach continuing to go by the book, no issues whatsoever with the SpaceX cargo craft. Dragon and the International Space Station now just 52 meters apart, approaching the coast of Namibia, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator. All of Dragon's systems continue to operate perfectly, approaching the 30-meter station keeping point some 5 minutes from now. Currently flying over the border between China and Mongolia. We're about 6 minutes away from capture point. Dragon just 18 meters away.
You're in step 4.
The end effector is approaching the pin, standing by for capture. Capture confirmed. At 6:23 a.m. Central Time over the Pacific Ocean west of Hawaii.
And Houston Station on Space to Ground 2, we show load safe, and looks like we caught a Dragon, and you'll go for post reconfiguration.
Copy station, there are smiles all around here. Nice job capturing that Dragon.
I have been kind of wowed by a thing that Mitch Yao has been working out in Sunshine, Arizona. He's been threatening me with this device for 2 years, and I like it. I like the idea, and I like the product that he came up with. It's very bling, and it's very useful. It basically gives us an easy interface, which is what we've always lacked, for both the Siemens motor and the UQM motor to do a direct drive to a rear drive vehicle, and with a 2-to-1 planetary gear reduction, achieve our goal of about an 8-to-1 gear reduction for electric drive. Let's take a look. Well, we have some new bling to show you. Kind of excited about this. It's this guy's been threatening me with this piece of equipment for 2 years now. I've kind of given up hope. This is a UQM Power Phase 100 motor from the Coda bankruptcy. We have new ones from UQM, and we also have some from the Coda thing. We polished this one up, and that's to show it off with our new toy piece of equipment called the Torquetrends Torque Box. And this is kind of what it looks like. It comes with an adapter plate and a little transmission. The transmission is simply a 2-to-1 gear reduction that takes away all of the pain of mating up with either a Siemens motor or a UQM Power Phase 100. I had recently announced we were probably going to get out of the Gearbox business. We've sort of fallen out with Borg Warner Beijing, and their products have become very expensive. I never was a big fan of them, but I also wasn't a fan of direct drive very much. And Colin and his father, Tim, at KK Manufacturing, demonstrated a pretty able conversion of a 1959 Mercedes-Benz SL190 using direct drive, and they found the acceleration directly to the differential to be quite pleasing. I doubt that I would, but there's a way to get there. The UQM motor and the Siemens motor, of course, have the little stubby spline shaft. And so you have to make an adapter plate, a coupler to the transmission. We've shown various strategies and carry several products to enable you to do that. None quite this easy. This is developed by Torquetrends, is a fellow named Mitchell Yao and his wife Grace out in Surprise, Arizona. And they have made this 2-to-1 planetary gear set reduction that on one end has a shaft specifically for the motor, the UQM or the Siemens motor. It actually has the splines and goes right over the shaft of the motor. And then they have an adapter plate that is made just for that motor that you bolt up to the motor, and then you bolt the torque box planetary gear set directly to the adapter plate. And what that gives you is a 2-to-1 gear reduction out of your motor. If you take that 2-to-1 gear reduction and put it into your average rear drive car differential, you'll find most of those run from 3.75 to 4.25 to 1 in the differential. And so if it was a 4 to 1 differential and a 2 to 1 gearbox, torque box, you would wind up at 8 to 1. Our most popular e-gear drive gearing is 8.25 to 1. The Tesla uses 9.73 to 1 with a very high RPM motor. And then, of course, in the Coda with the UQM, they did a 6.54 to 1 e-gear box. And so simply by adding a 2 to 1 planetary gear reduction to the Siemens or the UQM motor, we are right in exactly the zone 7.5 to 8.5 to 1 ratio through the differential of a standard rear drive car. As I said, it bolts, we have an adapter plate that bolts very simply and very easily right to the motor. It's designed for the motor. And then the shaft of the torque box fits right over the spline shaft of the motor. And it has 6 bolts that then go all the way through the unit into the adapter plate. And so in about 20 minutes, you can solve all your mating problems to your car and be left with basically a yoke on the end, and you connect your drive shaft yoke to that, and of course you have another yoke at the rear end of the differential. You want them to be pretty much lined up. If it has to be a different length, even a little town the size of Cape have people that cut drive shafts. They're just, it's very commonly done, and so you can find somebody to do that almost anywhere, and fairly inexpensively. And so we think this device will make mating a UQM or a Siemens motor to a rear drive vehicle. This obviously doesn't work with your VWs and some of that, but a Corvette, Camaro, Buick Riviera, etc. This has to be the simplest install of a motor and adapter that there is. It's a very high quality unit. It uses 300M steel for the working parts, 6061 T6 aluminum for the exterior, making it a very blingy looking thing. You use synthetic automatic transmission fluid in it to lubricate it, and it has a drain hole and a fill hole. And you can, the yoke is held on with a simple nut. You can change to a different style yoke if you need to. It's quite heavy duty. This will handle 800 foot-pounds of torque from the motor, and that's, which is, of course, the UQM puts out about 300 Newton meters. So this thing is heavy-duty overkill beyond anything, and a true planetary gear system to give you a 2 to 1 gear reduction. And so we think this makes an absolutely gorgeous combination of a very shiny metal that'll drive your car very capably, but more importantly, it really eases the pain of the adapter plate and getting machinist and the coupler and the flywheel and the whole thing, and totally eliminates your transmission, giving you a single speed car. It's very simple, very robust, very reliable, and but still have sufficiently good performance to be attractive. And so we think this is going to be a great deal. It's unfortunately priced, I think, at $4,495. It's very expensive, but very high quality. And again, you're going to be $1,500 or $2,000 into mating your motor to your car anyway. And this sure makes it easy and pain-free and very effective. And so I think it's going to be a big deal for us, even at that price. Mitch has done some videos describing in further detail the inner workings of the Torquetrends torque box for electric vehicles.
Hi, Mitchell Yao, Torquetrends Incorporated. Today we want to share a short video on the gear train and the power flow in our torque box. Alright, this is the torque box. This particular torque box is for an EV. It's a 2-to-1 reduction. Our unit is based on a compound planetary gear set, and really simple unit. We'll go through the component pieces and then we'll discuss the power flow through the unit. This is the carrier housing, the housing that you see right here. It holds the planetary gear system, supported actually in the tail housing with a double deep groove ball bearing that sits here on the output shaft. On the other end is the coupler and input shaft combination. The input shaft is splined into our coupler. Input shaft is 300M steel with rolled splines, and it's splined into our coupler. See, there was a little difficulty pulling those apart. That's because there's an O-ring that seals on the machine part of the input shaft, a coupler that's retained in a groove inside the coupler, backed by a snap ring. So it's about a 20 thousandths compression fit. When you push those two together, that's to prevent spline leakage from the unit, fluid leaking through the splines down out the coupler and create an external leak. That is a Viton seal we use there. Okay, on the coupler we have retained with a spiral lock ring a steel roller bearing. The housing is steel. The balls themselves are ceramic for our EV units. They're steel in our non-EV units. But because of the high RPM, the high speed on the input side, on the EVs, 12, 13,000 RPM, some of them, we use a ceramic ball for that ultra high speed. So on the coupler side then, we're splined to whatever motor shaft or transmission output shaft that we're trying to fit. Same basic unit with different ratios, different adapters. You could find in off-road race vehicles, in lifted big tire trucks, or in EV converted vehicles. So this particular one being for an EV is a 2-to-1 ratio. Inside the carrier housing is a fixed sun gear. That central gear, the sun gear, is splined into a flange, and that flange is pinned and bolted. There's 3 pins, alignment pins for proper alignment. This sun gear has to be dead center in this housing. So it's on alignment pins, and then 6 bolts retain it. They are Loctited in place. It's a 9310 material on that gear, rim polished, and then a special treatment, special coating to give it some real endurance. In that carrier housing we have a drain plug on the bottom. You also see alignment pins here to align the housings, keeping everything properly centered, properly engaged. On the other end you see a large O-ring here. This is also Viton material. It's good for about 400 degrees temperature. Not that we ever see that, but it's just about the best seal you can buy. And you notice that the way that we're sealing our unit with this O-ring with about a 20 thousandths compression fit is in the inner diameter of the next housing we're sealing into it. So we're not using a gasket or an O-ring on the mating surfaces of our housings. There's 4 different housings here. You have a tail housing, a carrier housing, an input housing, and then whatever adapter. So we're using these Viton O-rings to do our sealing, and they do a perfect job. Okay, the planetary gear set itself, we'll talk a little bit about that. It's a billet housing, 9310 gears. There are 3 tall pinion gears and 3 short pinion gears. And then all the way in the back in the center is the reaction sun gear. Now note that on this particular planetary system, the output shaft and its flange, or what they call a nail, that's one forging, is bolted to the carrier. And that's really important. If you were to damage a carrier or damage an output shaft, you can simply unbolt it and replace the damaged part. Most planetary gear systems on the market, the carrier housing, the output shaft, this would be a welded connection, not bolted. So this is where we're running the double deep groove steel ball bearing to support the planetary gear set in the housings. And then we use a bolt-on yoke. It's a custom steel nut. It's a grade 8 steel nut that gives us great thread contact, and this gets torqued to about 150 foot-pounds. We don't want any in play in this unit, so as we assemble, or when we assemble this, we're using shims. We start with a large spacer against the planet set, and then from there we use shims to get the proper spacing, properly place the bearing in the housing, and then bolt everything down. We don't want to overly load this bearing. We basically want 0 in play. 1/1000th is fine. It's going to go away with a little bit of heat expansion, but we don't want to, when we torque this nut down, we don't want to be putting a lot of end loading on this bearing. We just want to take out the end play. So that's a very simple procedure for measuring that. You can simply, without shims, you can put your bearing on, put your yoke on, torque your nut down, and then there'll be a space or a gap between your bearing and your yoke. You can measure that and with the actual shim, and stack the shims that you need to fill that gap, or you can use feeler gauges. So pretty simple unit, very heavy duty. And now let's talk about the power flow through the unit. Once more, we're splined on this end of the coupler to the electric motor in an EV, or to the output shaft of the transmission in a gas-powered or diesel-powered vehicle. So the power flow in our unit is from the coupler to the splined input shaft. Other end of the input shaft is splined into the reaction sun gear in the center bottom of the planetary gear set. That sun gear is in constant mesh with the 3 long pinion gears. Those long pinion gears are in constant mesh with the short pinion gears. The short pinion gears are in constant mesh with the fixed, the stationary sun gear. And since it is fixed, it does not turn. They revolve, they walk around the fixed sun gear. So the power flow then is from those short planetary gears, or pinion gears, to their pins, their individual pins. Again, there's 3 of those. And from the pins to the carrier housing. And we've already seen that the carrier housing is integral with the output shaft because they're bolted together, pinned and bolted together. So again, power flow, coupler to input, input to reaction sun gear, to the long pinions, to the short pinions, to their pins, to the carrier housing, to the output shaft and out. That's the power flow through the unit. There is no shift. It's not a 2-speed. It has no neutral. It's a reduction gearbox. So whatever you've got coming into it, it's going to be reduced by the ratio of the gear set that we choose, gear set that you choose. And we've got gear sets from a 1.58 to 1 up to a 2 to 1 and several ratios in between. And we're currently working on even deeper reduction for some of the RVs from the track cars like autocross, things like that. So that's the component pieces of the drivetrain and the power flow. Thanks for watching. Okay, we're back with another short video, and this one I want to do just a quick disassembly, show you all the component pieces of the torque box. So I've already started the disassembly just to make it a little quicker. We are running a fixed yoke, as you may have seen on an earlier video, fixed yoke on the back of our unit. We've got 6 long through bolts that bolt our assembly to the adapter. And just left one bolt in here to hold it together. We'll back that up quickly. And we'll start looking at the individual component pieces. Okay, so now we can wiggle the adapter off of the front. This is the adapter plate. There's numerous different adapter plates depending on what we're fitting. Some are square, some are rectangular. This one is for a Turbo 400. It's a 6061 T6 material. It has 2 alignment pins. All of our housings have pins. They're all in line and just keeps everything centered and straight. You'll see also 6 steel inserts. So when we tighten this unit down, we're not tightening, we're not pulling against aluminum threads. When we're torquing these to specs, we're pulling against these steel inserts, very strong. We also have a seal. This is a Viton seal. A very high quality seal. It'll go the distance. To hold the unit together, when we're taking this assembly off of a vehicle, maybe we're underneath the vehicle and we've taken the 6 through bolts out, pulled it off of the adapter, which is still bolted to the motor or transmission. Now we've got this unit in our hands. And by the way, this is just sitting on a show stand or platform. This base is not a part of the actual unit, just for show. And so what we wanted to do was keep all this together. We didn't want this falling apart, coming apart, making its way to the workbench, but to stay fully contained. So what we did was simply run a couple of reverse through bolts from the front back. And they come through and all the way back into the tail housing, and not much torque. We do have a torque spec so that you don't over tighten, but it's really just to hold the housings together to get you safely over to the workbench. Hopefully a nice clean environment to work on the unit if you need to. So just a couple of reverse through bolts. Now we can actually take the housings apart. I can just wiggle the tail housing off of its alignment pins. The other thing that's kind of making it a little stiff to pull off is the O-ring. There's a large O-ring. It's a Viton O-ring that's sealing into the next unit inside. So we're not sealing against the flanges. No gaskets whatsoever. There's no gaskets in this unit. Just internal O-rings. About a 20 thousandths compression fit inside the next unit. And that's the way our unit's put together. That's the way our unit's sealed. So a little bit more about the tail housing now. Also 6061 T6 aluminum. The billet piece gets whittled into shape, and it It has a press fit bearing. This is the output shaft bearing. This is what supports the entire planetary gear system. It's a double deep groove ball bearing. It's pressed into place from this end. It gets pressed in. There is a stop built into the housing here. It can only go so far. And then it's retained with a very heavy duty snap ring. Hopefully you can see that down in there. Big snap ring in there. It takes a heavy duty pair of snap ring pliers to get down in there and get that snap ring in and out. We also have a fill plug in this housing. No alignment pins on this one. The alignment pins are on its mating housing. So that is your tail housing, with the exception of a rear seal, and this is a Viton double lip seal that is a light press into place and then is retained with a spiral lock ring into the final groove. So no matter what, the seal is not coming out. And double lip prevents the dirt and water from getting into the unit, keeps the oil in the unit. One last thing I want to show you on this, the two small holes you see here, this is for oiling. Can you see that? Get the angle right in the light. You have a tapered hole. Now you get oil on this side, oil being splashed around on this side. It's not a pressure unit, it's a splash lubrication unit. But we do have oil, and the oil makes its way through those holes and back behind the bearing. We're running a sealed bearing, but back behind the bearing, hitting the shaft and coupler area, or shaft and yoke area, being splashed onto the back side of the seal. And that's very important for seal life. Keep the seal temperatures down. We've got to have oil being splashed to the back side of the seal. So that's what those holes are for, and they do an excellent job of getting oil onto the back side. Next we'll pull out the planetary gear set. We've seen all about the planetary gear set in another video, or if you haven't seen that one yet, look for it. Now we're looking into the carrier housing. We see the input shaft is splined in, it splines into the gear set, and the fixed sun gear or flanged sun gear inside the carrier housing. Carrier housing has the two alignment pins on it. It also has the drain plug in the bottom. That's how I've affixed it to this show plate. Let me grab another one here. There you can see the bottom of the unit with the drain plug. It's an O-ringed drain plug. There you can see it from the inside. So now we can take the input housing off, just kind of wiggle it off of its pins. Tap the input shaft. Okay. So here again you see the large O-ring, Viton O-ring that seals inside the inner diameter. The two alignment pins to keep everything nice and straight. Now the bearing here is a light press into the housing, and then the coupler has a spiral lock ring on it. We have a Viton seal on the front side of the coupler, and we have a vent in the top. And typically what we do with this is we're running a hose on this, running a hose up higher, usually underneath the hood, to a small reservoir. We can vent through that reservoir, or we can even use that for filling the unit, but we do have to pull the fill plug. When we fill the unit, we have to pull that fill plug or it won't accept fluid. It'll be airlocked. So we're pouring fluid through the vent. It can't vent through the vent. So we've got to pull the plug in the back, and we can put fluid through the top, a measured amount. It holds 1 quart. If you've got the plug pulled in the back, take it completely out, you're basically wanting to fill to the bottom of those threads. It should be, in most vehicles, depending on the angle of the vehicle, the angle of the unit, would be about 30 to 32 ounces of fluid. We recommend Royal Purple synthetic, ATF, or any good synthetic, fully synthetic ATF. You do not want to run a heavy gear oil or even a 1030 type motor oil. It's just too thick for the tight clearances we have in this unit. A thicker fluid is just going to be pumped out. It's going to hydraulic, it's going to pump fluid out through the vent. But with the ATF, not a problem, it does not vent. So we can fill through our hose, through our reservoir, underneath the hood as a convenience, or we can just go underneath. If we're underneath the vehicle or have a hoist, easy to get underneath the vehicle, we can just fill through the fill hole until the fluid comes back out. We've got it full, put the plug in. Don't want to overfill the unit. If you do, it will seek its own level, it will vent fluid, and if you don't have a reservoir, it'll make a mess. So we don't want to put too much oil in it, we just want to make sure that it's full. So we covered the adapter housing, the input housing, the carrier housing, and the tail housing. There's 4 different housings, so there's 4 different sub-assemblies. So you can build your sub-assemblies first and then do a final assembly on the unit. Every unit we build then goes to our test bench. We do a spin test. We run the unit for a while. We measure temperatures, listening for sound. We're measuring the amperage draw on the motor that's turning the unit. So it's a lot of quality control goes into the unit before it gets packaged for shipment. Thanks for watching the video. Check out our website at torquetrends.com.
And so that's about the story about the Torquetrends torque box. They're making these in fairly low volume, fairly high cost, but man, what bling. If you're thinking about doing that classic rear drive car, this is a way to use a fairly small motor to get fairly good performance out of a fairly large vehicle, and have a very easy to operate, easy installation, and a very simple, and you know, you're eliminating a lot of weight when you take out that internal combustion engine and the transmission and replace it with this. This is about 110 pounds. This is another 50 or 60, and you wind up with a fairly lightweight drivetrain that's quite strong and quite capable. And of course, it's easy with a Jev Q to make this go forward and reverse. And so it makes a very effective situation there. We have that in the web store now, but I wanted to take a few moments and show you the new bling and let Mitch tell you a little bit about his product. I think it's a step forward. Stay with us. Yes, he's very proud of it. I would note, however, that in addition to being ideal for direct drive and really making, you put together a UQM in one of these things and drop it into a car in 45 minutes. Measure the shaft, have that made, and it's another 20 minutes to put that in, and you're basically all the drivetrain parts are done. Since this typically has to be engineered, fabricated, and often at a cost of $1,500 or $2,000 anyway, or an e-gear drive at $3,000, $4,500 is proud. He's very proud of this device, but it's man, you can't beat the build quality, and it sure does take care of the bill. And so that's about it. It's been a couple weeks since I've done a video trying to put this together quickly. But this is Chad Felix drive unit for his 34 Ford Roadster. It seems to be working perfectly. I can put it in neutral. I again have to press the brake switch to put it in reverse, and we're immediately backing up there. And so this thing is just operating as smooth as it can be. We've got a nice display. Maybe a little software problem there. I'll get you an update, Chad, on reverse on RPM. You're showing about 65,000 RPM. Miles per hour, however, is rationalized, so I think I can get that worked out. Pretty basic software problem. And we'll have a way to send updates to our people who have these installed in the car. You'll just take a laptop and click on a file, and it'll launch itself into there and update it. That's part of the miracle. The way we're doing it is, it's the whole idea is for it to be relatively easy. That's also the miracle of how much time all this has taken to put in kind of a pseudo product form where people can be able to use it, and that's our mission. We're getting closer step by step. This will be the second one we've shipped, and I'm anxious to get return information from both those guys. We have a third sort of beta tester who's already been working with us on the Quaife end of it up in Victoria, British Columbia. But that'll give us a small set of people to have 2 or 3 out there operating, going in vehicles, and get some feedback from them as we go. That's always a big part of the process. I would love to say that everything we ship is 100% guaranteed perfect from the very first unit. However, that would be kind of like running for president, where anything you say is okay, and not to be termed a lie. So, how about that Trump, huh? Geez, are they going at it this week? In any event, that's our show this week. Just some drivetrain updates, really. Congratulations to Elon Musk. The guy is hitting on all cylinders, so to speak. We're delighted to have, and as you can see, I've got one wheel turning and the other one not. It is, I can spin them both up. But that's that open differential, you see, and in reverse. And so there we have it. I can turn creep off, and we drop to a couple miles an hour. And then put it in park. And that's, since I don't have any cooling hooked up and we're strapped up, ready to ship, that's about enough of a run. But we're going to box these components up, put them on the pallet, shrink wrap it, strap it, and call a truck and have this delivered to California this week. So, Chad, I'm sorry it took a week or 10 days longer than I said, but I wanted to get you a pretty good set of software and it running smoothly along the way. Stay with us. There'll be more EVTV irregularly. See you soon.